Increments. Now that you have a good idea about the three main exposure settings, and where you can see them on your camera, you can look at how the values change as you select them. When I say increments, I am talking about the actual step values of the aperture, the shutter speed, and the ISO. You can skip this increments section if you like, but if you want to know what they are and how your camera presents the values to you, then it may be worth a look. Let's start with the aperture values. Increments. The aperture. As you change the aperture setting, you will find the values or steps displayed on your camera screen change as follows: f1.4, f2, f2.8, f4, f5.6, f8, f11, f16, f22, f32, f45. It is important to remember that the difference between one value and the next is one full f-stop. The f value can also be altered in half stops or 1/3 stops. More about that and how to do it on the next slide. Note that your lens may not have an aperture setting of f1.4 or even f2, as your aperture in the lens you are using may not be mechanically able to open that wide. Also, the aperture may not be able to close as small as f22 or f32 or f45. You will be able to see as you change the values, the range of aperture settings for the lens you are using. Now here is an interesting bit. Not massively essential to know, but it does add to your understanding of how the aperture is designed to control light entering the camera. Let's say you set your aperture at f4. When you change the setting one full step to the next f-stop above, which is f5.6, you are, as we have already learned, making the aperture smaller. This one full f-stop reduces the amount of light getting through the lens by half. When you set the aperture to the next full step above, from f5.6 to f8, you are reducing the size of the aperture again, and in doing so, reducing the light entering the camera by another half. For every one full step up, you reduce the amount of light getting through the lens to your photo sensor by yet another half. By f22 and beyond, there isn't much light left getting into the camera. Obviously, when we change the f-stop value in the opposite direction, we are doubling the amount of light getting through the lens. The physical size of the aperture does more than just control the amount of light getting through the lens. If you remember earlier, I mentioned something called depth of field. DOF is directly affected by the aperture size. We can look into what DOF is and how it is affected by the aperture at a later date. Increments. The aperture. Remember, we said that the aperture values can be changed in half stops or 1/3 stops. This means what it says. Instead of full stops, we can make smaller half stop or 1/3 stop changes. Look and you will find a setting somewhere in your camera menus that will allow you to select half stops or 1/3 stops. To clarify, if you select thirds, you will find the f-stop values change in smaller increments of 1/3 of a stop value. This means, for example, a lens with the widest aperture of f2.8 will have increments as follows: f2.8, f3.2, f3.5, f4, f4.5, f5, f5.6, f6.3, f7.1, and so on. It is not important to remember all these figures. All you need to know is, as the number rises, the aperture diameter gets smaller, letting less light into your camera and vice versa. Increments. The shutter. Let us set our shutter value at half a second and see how the values change as we make the shutter speed faster. Every change in value doubles or halves the shutter speed depending on which way we change the value. Take note, this is altering the shutter speed by one step. There are shutter speeds faster and slower than the ones I have shown, but I have chosen this small section for demonstration purposes. 1/2 of a second, 1/4 of a second, 1/8 of a second. 1/15 of a second, 1/30th of a second, 1/60th of a second, 1/125th of a second, 1/200th of a second, 1/500th of a second, and so on, doubling the speed every step. Note, 1/15 and 1/125 are as close as the shutter can represent 1/16 and 1/120 of a second respectively. Important. Changing the shutter speed by one full step has the same effect on how much available light the sensor is subject to as changing the aperture value by one full stop. Simply put, you can double the amount of available light hitting the photosensor by widening the aperture by one full stop. For the exact same effect you can instead half the shutter speed by one full step so that the available light will hit the sensor for twice as long. Either one will affect the exposure in exactly the same way. Do not confuse stops with steps. It is the aperture that is measured in f-stops. Once again, like the aperture, smaller increments can be selected by selecting half steps or third steps in the camera's menu. This is something that you can look for to make your selectable shutter speeds more like this. These values are changing in thirds. 1/2 of a second, 1/2.5 of a second, 1/3 of a second, 1/4 of a second, 1/5 of a second, 1/6 of a second, 1/10 of a second, and so on, giving you a lot finer control over your exposure. Remember, it is not important to remember all these figures, you just need to take note that the faster the shutter speed, the less time the photosensor is exposed to the available light. Also, the faster the shutter speed, the less chance of a blurry photograph due to camera shake. It may be a good idea to point out here that you can put your camera on a tripod to prevent camera shake. Keeping the camera totally still on a solid tripod means you can use slower shutter speeds without getting blurry photographs. Obviously, this is only a good idea if what you are photographing is also perfectly still. There are times when you may want the object of your photograph to move in a long exposure, but not its surroundings. This is another lesson for later. Increments. The ISO. What does the ISO value have in common with the aperture and the shutter values? You've guessed it, the halving and doubling of its effect on exposure. Each full step of the ISO setting halves or doubles the sensitivity of the photosensor depending if you increase or decrease its value. One full step of the ISO value has the same effect on your exposure as one full step of the shutter speed or one full f-stop of the aperture. As you can see, all the three main settings are connected when it comes to their effect on exposure. The ISO sensitivity scale in some cameras starts at 64, so in full steps, we have 64, 100, 200, 400, 800, 1600, 3200, 6400, and so on. The more expensive and modern your camera is, the higher the ISO numbers go, therefore the higher you can make the sensitivity of your sensor to light. The Nikon D850 for example has an ISO value of 25,600 and there are more sensitive settings beyond that, but at those super high values, photo quality as we will see later is drastically affected. The ISO scale in your camera's menu can be set to half steps and third steps just like the shutter and the aperture values can, so that you can have ISO values of 64, 80, 100, 125, 160, 200, 250, and so on. And once again, you don't have to remember these numbers, just the fact that the higher the numbers are, the more sensitive to light your photosensor is. As mentioned earlier, for our purpose and in good light indoor or outdoor, we can set the ISO to 100 as a starting point that will not produce any grainy effect on your photograph. In the next part of our tutorial, we are going to teach you what the camera does with the three values you set. Please don't forget to subscribe.